Okay, so we talked about demand and supply. I haven't yet built the supply curve, so I kind of want to show you where that comes from. We'll talk a lot more about that when we talk about producer theory. Um, but for the sake of just kind of giving you a bigger picture, we're going to talk about we're going to build the supply curve, and then I'm going to show you what equilibrium is, kind of intuitively, and then I'm going to formally define it in this next slide. Um, but the general idea behind equilibrium is that when it's at a point where you reach kind of consensus in the market, where everybody who wants to buy buys, or everybody who wants to buy at a particular price buys, everybody who can't buy at that price does not buy, every buddy who wants to sell sells, and everybody who can't sell at that price doesn't sell. And it's kind of a consensus that the market reaches where supply and demand kind of essentially talk to each other via that signal that I keep bringing up, in order to basically show what the relative scarcity or relative abundance of a particular good is and how many people want it. So let's build the supply curve, and then I'll show you exactly what I'm talking about. Okay. All right. So here we have 3 different hot dog companies. And what I'm going to do is I'm going to use their marginal cost, which is the cost to produce the next additional unit. Remember, marginal is always the next additional unit. So this is the cost moving from the second hot dog to the third hot dog, or the cost from the third hot dog from the fourth hot dog. Okay. So we're going to use the marginal cost to we're going to come up with some random marginal cost that we just kind of created out of our head. And then we're going to use that to map it to prices. Okay, and then from there, I'm going to plot it on that same graph as before. So right now it's just this little green line. Okay, I'm going to plot it on the same graph. Okay, and then we're going to compare it to demand, and we're going to see. So just like we had some willingness to pays that we just we assumed. These ones followed the idea that of diminishing marginal utility, but they were ultimately just assumed. So based on those willingness to pays, we did a demand schedule, and then we did the demand graph. Similar, we're going to use marginal cost, which is kind of the underlying foundation behind a supply curve. We're going to use that, and then we're going to build it to a supply schedule, and then from the supply schedule, that'll build a graph. Okay. So again, marginal cost is the cost of the next additional unit. So my marginal cost here will be the cost to produce the second hot dog that wasn't incurred already by the first hot dog. Okay. So let's say the marginal cost for the first hot dog was 10, 8. Sorry, I want to go the opposite way. I want the marginal cost to be increasing here. 2, 4, 6, 8, 10. Oh. And let's do 3, 5, 7, 9, 11. And let's do 1, 4, 5, 6, 8. So just kind of random there. And I want to bring these guys down. Oh, sorry, I'm just going to bring this one down here. All right. So these are just random marginal costs that I kind of just, threw out there. So if the price is 0, how many hot dogs does Frank want to produce? Okay. So Frank isn't going to produce above his margin. He's not going to price above his marginal cost. In fact, he's only going to want to price where his average total cost is greater, and average total cost is actually higher than marginal cost for the first couple units. But at any rate, let's just say that there's no fixed cost for now. These are terms I'm throwing around: fixed costs, average total cost. You'll see them later, and I don't want to scare you, so don't worry about those. But let's just say that Frank is not going to produce unless the marginal cost is lower than his price. So he's not going to make the second hot dog unless it makes sense for him to make the second hot dog. And for it to make sense, he has to get more money back than he paid. And the money he gets back is his price, because he's selling the hot dog. And the money he pays is marginal cost. Okay. So for the for a price of 0, he's not going to want to make any hot dogs. Same thing with 1. From 2 to 4, he'll make 1 hot dog. And then he makes 2 hot dogs at 4. And 2 hot dogs at 5. And at 6, he's going to make 3 hot dogs. And then at 8, he's going to make 4. And then at 10, he's going to make 5. And then he finishes out at 5. Okay. And this could go in, it's increasing in price, but let's just say that they can only make 5 hot dogs. They could, if the price is high enough, they'll make $1 million. But for now, let's just say, for the sake of this, let's just say that they cap it at 5. Okay. All right. So I'd ask you to pause and kind of fill in your own supply schedule right here, and I'll give you a second. Just pause it, and then we'll do it as a class. All right, so let's build the supplies schedule for Hebrew National and Dietz and Watson. So until marginal cost hits 3, until price hits 3, his cost will be higher than his price. And then once it hits 3, he's going to want to produce 1. And then once it hits 5, he'll produce 2. And then 7, he'll produce 3. That should be 3. And then at 9, he'll produce 4. And then at 11, he'll produce 5. Okay. What about Dietz and Watson? So 0, 1. It'll be 1 until it reaches 4. And then it'll be 2. And then it'll be 3 at 5, 4 at 6, 4 at 7, and then 5 and anything above 8. All right. So let's cool. So then I just sum these guys up and you have your quantity supplied, and then I have it automatically to feed to the graph. So this is your supply function. This is your supply curve. Okay. This is a mapping between the price and the quantity supplied. So at a price of 10, they're going to be selling 14 hot dogs on total. Apologies, I'm pretty sure you can hear my cat scratching really loudly. I'm sorry. But please try to ignore him as much as I can't ignore him. He's annoying as hell. But at a price of 10, the quantity supplied will be 14. Okay, so that'll be and it'll be 14 because if the price is 10, that's high enough to justify Frank making all the hot dogs. Okay, it's high enough for Hebrew National to justify making 4 hot dogs, but not this 5th hot dog. High enough for Dietz and Watson to make all 5 hot dogs. If the price is 2, right, then Frank can justify making 1 hot dog, but not the second one. Hebrew National can't justify making any hot dogs. And Dietz and Watson can justify making 1 hot dog, but not a second one. Okay, because 4 is greater than, the marginal cost of 4 is greater than the price of 1. Okay. So here's your graph, and see this little point right here? Somewhere around, looks like it's between like 7.5 quantity and 5 price, something like that. That's basically the point at which everybody who wants to produce has a buyer on the other side. Okay, so if you were to line up producers, the green line will give you the cost per producer, right? So like the higher the cost, the less, the higher the cost, the higher the price has to be in order to justify the quantity supplied. So like we had high marginal cost towards the back end here, right? So you need a high price to justify that, basically, right? So everything here is high priced. Everything here Sorry, is high cost, also high priced. Everything here is low cost, low price. So as the price rises, the higher cost hot dogs are going to be entered into the market. Okay, so the supplier, Frank's or Hebrew National or whatever, will make more hot dogs as the price increases, because as the price increases, it becomes profitable to make hot dogs because their cost is kind of set. So if this is your cost, you're gonna, and this is your price, you're not gonna enter the market until when price is greater than or equal to cost, right? So as price starts beating out cost, more and more hot dogs go into the market. Alternatively, on the demand side, as price is high, consumers aren't willing to pay $13 for a hot dog, right? But as price drops, more and more consumers, so like this guy really likes hot dogs. This is the guy who really loved hot dogs. I want that $13 hot dog or that $12 hot dog, right? I want that $12 hot dog. I want that $12 hot dog. Sorry, I was watching Eric Andre earlier today, so I'm in a bit of a mood. So, excuse me for a second. So this you got one guy who's really willing to pay for one hot dog for $12. But after that, it takes a little bit for the next guy to want to come in, and then the next guy will come in if the price drops a little more, and the next guy if the price drops a little more, et cetera, et cetera. So basically on this side of the demand equation to the left, you have the people who want it the most. And on the right, you have the people who want it the least, right? This guy isn't willing to pay anything for the last hot dog, right? So nobody's willing to pay anything for a 15th hot dog in the market. It has no value, okay? But the one guy is willing to pay, $12 for the first hot dog. But when there's 15 hot dogs in the market, nobody's willing to pay. So like you'd think that as long as there's someone who wants the hot dogs more than the cost of someone who wants to sell the hot dogs, then these guys should enter in some sort of trade, right? So at this point here, someone wants a hot dog and they're willing to pay $7 for it. Okay, so this guy here, someone wants a hot dog, or someone wants to sell a hot dog and they're willing to sell it for $4 or more. So these guys can make a trade somewhere between $7 and $4. Okay. At this point, someone wants a hot dog for, it looks like $6. Okay, and there's a guy over here who's willing to sell a hot dog for anything over $5. So they can trade somewhere between $6 and $5. Okay, and that's basically what an equilibrium is. When you can find a buyer for something you're willing to sell. Okay, and they're represented by the intersection, because the intersection will give you all the people on the demand curve who want the good a lot, and all the people on the supply curve who are willing to supply it for a little. Okay, so as long as someone's willing to supply it for a price that's less than or equal to what you're willing to pay for it, you should be buying that hot dog. And at this point, right where they intersect, basically that's the point at which there's really no one who wants to buy for a price higher than someone is willing to sell. Okay, so like this guy is willing to buy a hot dog, but only if it's greater than a price of $6. Okay, this guy's willing to buy a hot dog, but only if it's greater than a price of $7. Okay, but all the people who are willing to sell the hot dogs aren't willing to sell it at anything at anything higher than 5. It looks like. Okay. I'm sorry, I misconstrued that. Take that back for a second. Okay, this is still the supply curve. So this guy's willing to supply at 6. This guy's willing to supply at 7. This guy's willing to supply at 8, right? But there's no buyer who's willing to buy for 6, 7, or 8. The next buyer will be willing to buy for 5, or for 4, or for 3. Okay, So at this point, there's going to be unmatched hot dogs. So in the long run, these green suppliers who have high costs won't want to enter the market, and they'll stop producing the hot dogs. These guys will stop trying to buy a hot dog, and you'll reach an equilibrium quantity where the number of hot dogs supplied is equal to the number of hot dogs demanded, and they kind of agree that it's going to settle at some place between $5 for a hot dog and $6 for a hot dog, based on the two last people who are like the last ones willing to trade. Okay, so one question you might ask is like, why doesn't this guy down here, who's willing to pay $3 for a hot dog, trade with this guy who's willing to pay, or who's willing to supply the hot dog at $1 because his cost is $1? They can, but these guys up here are going to drive the price higher. Everybody to the left is willing to pay a higher price than this guy over here, right? And by virtue of wanting to pay a higher price, they're going to kind of bid the market up. Okay, so these guys really want their hot dogs, and they're really willing to pay for it. And the suppliers aren't dumb; they know that, so they're gonna want to charge the max that they can get, and these guys are going to want to pay the minimum that they can get, but as long as they get the hot dog, because they're willing to pay for the hot dog, right? So these guys are going to basically outbid these guys down here. So the equilibrium price is going to converge at this point between the two last buyer and seller. Okay. So like even though this guy is willing to buy it at 3 and this guy's willing to sell at 1, he knows that there's a better buyer who he can kind of charge a little bit more from, because that guy will eventually outbid this guy, right? If he says I want to pay 3, this guy would kind of be bumped out of the market over here. The guy who's willing to pay 6, but would be like the last person to trade, right? So like if this guy steals his spot, then I'll say, all right, you want to sell it to him for $3, I'll pay $4 for it, and then this guy's already out of the market. So then it'll just go back to this, and that's basically the definition of equilibrium, is that it's like a settling point. There's no real deviation you can get, even though this guy can benefit from buying from another guy, this guy over here. This guy knows that this guy would rather buy the good, so he's going to sell him the good, and he knows what his willingness to pay is, so he's going to sell him for closer to his willingness to pay. Okay, so there's it's a game essentially. It's an auction, right? If you know that there are people who are willing to pay a lot for what you have, you're going to want to sell for as much as you can, right? Otherwise, you're just not pricing effectively. So why sell it to the person who's willing to pay $3 when you can sell it to the person who's willing to pay $6, right? And if this person who's willing to pay $3 does end up getting the good, basically someone's being bumped out of the market, someone with a high willingness to pay, right? So they're gonna try to upsell the good. They're gonna try to bid up the good closer to their willingness to pay. And just to kind of preview next lecture, I'm going to start talking about consumer surplus and producer surplus and Pareto efficiency and all that. But basically, if this guy is willing to pay $6 and this guy is willing to pay $5, and they agree on a price of $5.50, they're both better for having made that trade, right? They both gain 50 cents relative to, like 50 cents of utility relative to what they were willing to pay or willing to sell it for. Okay. Whereas if this guy sells it for, or buys it for 3 from this guy, right? This guy, he could get a higher value on it. And all that I'm trying to say is, like, in an ideal market and in a market as it appears here, what's going to end up happening is everybody who is low cost is going to want to produce the good. Everybody who's high willingness to pay is going to want to buy the good. Everybody who's high cost, higher than the price, in fact, everybody whose cost is higher than the price will not produce the good. And everybody whose willingness to pay is lower than the price will not consume the good. Okay, and if we were to deviate from that, we are actually taking away the total, we'll call it surplus from the market, the total, gains from trade from the market, because this guy values the good more than this guy. All right. So in a nutshell, that is equilibrium. It's the point at which there's always a buyer and always a seller, and they agree on a particular price. And at some point, the buyers and sellers, match until they reach an equilibrium quantity at which there's no buyer willing to pay for a good, given what the suppliers are willing to sell it for. So it's a match between the highest willingness to pay consumers and the lowest cost producers. Okay, that is your equilibrium, and it's always going to settle at one quantity, where quantity supplied is equal to quantity demanded, and it's always going to settle at one price. Okay, so an equilibrium can be categorized by one price, so in this case somewhere between 5 and 6, and one quantity, which will be equal to your quantity supplied and equal to your quantity demanded, and it's basically going to be this intersection here. Okay. All right. I'm going to stop it there, and then I'm going to go back into the slide and we're going to discuss it a little further.